So we will talk about your finals here and also your last 4 homework remaining. So and we'll see what kind of, and then I'll point out some stuff to review for your finals. So first thing first is your finals. So I'm gonna talk about your finals here. So for your finals, I think I sent you guys an email yesterday, right? So for your finals, it's gonna be take-home tests. It's gonna be on Monday, like this coming month, next Monday. I mean the 14th. I will post again the test in D2L, and I also will send to your college email address. So please do check it. And you got 24 hours to do your test. So by Tuesday, the 15th, December 15th at noon, you will have the test already in my mailbox. So no late tests, pretty much the same thing as your midterm that you took. Again, I want to see work. This is the one that I want to point out to you guys is if you don't show me any work, because I do have students in the last time in the midterm, they just give me 5. I don't know how they got 5, maybe from other friends, maybe from. So if you just give me the answer, but the answer is correct or wrong, I will give you a 0. Now, last time I'm kind of linear. I give them, oh, 5 is correct. I give you 1 point out of 5 because you didn't show me any work. But in this finals, if I didn't see any work, but your answer is all correct, I will give you a 0. Okay, I want to see work. Your work is what I want to see. Okay. So next, again, submission. You have to scan your test using a scanner or using any like cam scanner or any apps you have, and then send it to me to my school email address. So by Tuesday to noon. Okay. And then I have a final review. So I don't know you guys see this. So if you click on the final review, I know it's a little bit blur on the first page on the top part there. But so the final review is, where was that final review came? There you go. So this is the final review. It came from your textbook. I know the first top part here is pretty blur, a bit blur. So the rest is all here. So I would recommend you to practice all these questions, but do not forget, this is only 6, 7, 8. Your final include 11. So you have to look at chapter 11, which is series and sequences. I think that one you guys can handle that one because it's still fresh, but 6, 7 is especially chapter 6 and 7. So this is the one that is a good one for you to practice for my finals here. And yes, they all mostly come from here. So make sure you do the finals, the cumulative test 6 to 8. If you do not want to use this, you can actually go to your ebook, and then you go under chapter 8, and then you go towards the very end of chapter 8. It's called cumulative test 6 to 8 right here. And it's exactly the same questions as what I sent it to you. But the good news is the answer is right here. You see that? But if you use your textbook, the one I sent it to you, your answer is in your textbook at the very back page, and all the answers, including even odds, will be there. So I will recommend you guys, I recommend using the ebook because it's easier and it's clearer. So I will recommend you guys to use this kind of at ebook, and they are the same type of questions. Anyone have any questions with the finals here? Finals. So make sure, make sure you guys do this. It's very important. And your final is a 35% of your overall grade. So if you didn't do it, you probably get a D right there for the class. Okay. Next, we have your homework. So let's talk about your homework 8.6 here. Trigonometric form of complex number. You guys have any questions with this one?
No, I think we talked about a little bit of it last time, right?
Yep. The most important part about this trigonometric form of the complex number, which I talked about last week, is the quadrant. I don't know, you guys should did almost finish your homework here. Is your quadrant, because I still receive a lot of emails from you guys, like doing this kind of question number 5 here, or number 7 and number 8. Like they tell me, oh, 8 negative 8 root 3 is here, that is correct. Okay, because 8 is positive and negative 8, that is correct. But when they find the, use this in the trigonometric form, this is the one that a lot of students doesn't know how to do. Because R they managed to figure out because it's the square root of the two complex number square, like a distance. So it's 8 square plus 8 square root of 3 square. You guys know how to do this one? This is question 8. This is where a lot of students have a problem. So 8 squared is 64, right? And what is this one going to be? 8 root 3 squared. 8 squared is 64. What happens to this root 3 squared?
Does it cancel out?
Yep, so you will get 3. And then you have to multiply this. And Ryan, you are correct. This is 192. 64 times 3 is 192. And then you have to add those up and take what we got. 64 plus 192. So mostly calculators. 256. And then what is the square of 256? Is 16. So this is actually 16. Okay. This one, everyone, no problem. You guys got it. Theta is the one that a lot of students do it, got wrong because they see help me to solve this. In order for us to find theta is arctangent of the imaginary over by the real. So the imaginary is root 8 over 3 over by negative 8 root 3 over by 8. So your negative 8, 3 is the imaginary and the 8 is the real. And the 8 and 8 is cancelled. So this is actually arctangent of negative root 3. And they want this in radian. So does anyone, do you guys know what is arctangent of root 3? Tangent, what is root 3? Again, the answer is either 30, 40, or 65, 65, 40, 60 degrees is one of this. Tangent, what is root 3? Tangent. Which one?
Would it be 60, I think?
Is that 60? Oh, yeah. 60, sorry. 60, yep. Because 30 is root 3 over 3. Yeah, 30 is root 3 over 3. And 60 is pi over 3. That's correct. So again, they want it radian. So it's pi over 3. So a lot of, but this one is a negative. So a lot of students think, oh, negative for tangent is quadrant 2. So pi over 3 in quadrant 2 is 2 pi over 3. So that's why they put the 2 pi over 3 in the inside here, and you get all this wrong. Do you know why this is wrong? This is the one that you will see in your test. So a lot of students get this one wrong. Why this is wrong? Anyone? Because this, if you look at the graph, this is in what quadrant?
4.
This is quadrant 4. Yes. So what is pi over 3 in quadrant 4? Yep, 5 pi over 3. So your answer in this case will be 16 cosine 5 pi over 3 plus I sine 5 pi over 3. So this is the one that a lot of students ask me for homework help, is because of this wrong quadrant. So I just want to point out to you in the test, it's going to be the same thing. So be careful, because a lot of you guys will fall into this trick, and then you put 2 pi over 3, or some you put pi over 3 in here. So this one is correct. This is the one that a lot of, so make sure you know this is all belongs to quadrant 4 based on your graph. So I would recommend that even though the question in your finals doesn't ask you to draw the graph, I will recommend you to draw the graph so you know what quadrant it belongs to. Because a lot of students, oh, I didn't draw the graph, and then they just move on. Oh, this one, and that's why you get wrong. All right, so this is, yes, we did this last week. So I just apply again. This is what a lot of students make mistakes here. All right, next is the sequence and series. So chapter 11. So when you go to chapter 11, sequence and series, you do not need to worry about sine, cosine, secant, cosecant, tangent, cotangent, all these things, because in sequence and series, we do not do any sine and cosine. It's mostly just straightforward type questions. So it's actually not, and also formulas, a lot of formulas here. Let's talk about sequence and series. So this big sign is called a summation sign. It means it's addition. I think the 11.1, this kind is very easy, right? This should be easy because you just plug n is 1, n is 2, n is 3, and then figure out a number. So I think this one, you guys able to do this. You just substitute 1, 2, 3, 4, 5 into your n and put it there, and that's a number. Same thing here. But I want to point out to you about this number 10 onwards. This is the one that is not, because last time I give you the an terms and you give me the a1 to a5. This one is opposite. I give you a1 to a5, you give me the an sequence. This is the one that will be coming up in your finals next week. So my question to you is, do you guys know how to do this? I know this sounds easy, right?
This is where we use like a of n equals a1 plus n minus 1d.
Very good. So if you did arithmetic sequences, 11.2, yes, you can use this formula. Very good. See, this is what happens if you did your homework ahead, if you do 11, because this is an arithmetic sequences. What is A1 in this case?
-2.
And then n minus 1 is still n minus 1. And what is d in this case? D is the difference between this.
2.
Will be 2. And usually you need to kind of do a little bit more simplification. That means you have to distribute your 2 inside there. So you will get 2n minus 2. And then you combine like terms. So this is 2n minus 4. So if you find out if they're arithmetic or if they're geometric, you can use the formula. That's why I say chapter 11 is very heavy on formula. And this is a formula for arithmetic sequences. This is arithmetic sequences. And your answer in this case is 2n minus 4. How about number 11? 1/2, -1/4, 1/8, and -1/16, and so on. Is this an arithmetic sequence?
Geometric.
This is a geometric sequence, yes. And what is the formula to find a geometric sequence? An equals to
a1 parentheses r and to the n minus 1.
Very good. See, these are all the formulas that I mentioned, and you have to figure out, are they arithmetic or are they geometric? So that's why it's important. A1 is given to us by the first term, which is 1/2. What is r in this case? Do you guys know how to find r?
Divide the second by the first.
Very good. Yes. So if you have a geometric sequence, in order for you to find r, is you divide the second term with the first term. So the second term is 1/4 negative, and the first term is 1/2. So when you divide, so this one is the same thing as divided by 1/2. Which is the same thing as multiply by 2. Because when you change the division to multiply, you flip the half to become 2. So this r in this case is what? What is negative a quarter times 2?
Negative a half.
Negative 1/2. So this is negative 1/2 and minus 1. Okay. As usual, like last time here, you have to clean up a little bit. You have to simplify here by distributing 2. This one you also need to clean up a little bit. So what you do is this n power, you can separate them. So this n minus 1, you can split it into 2 like this. And we know that this, the negative, if you have anything with exponents with a negative, you can switch it around. So this is actually is negative 2. So when you have a negative 1/2 with the power of negative 1, you flip-flop this fellow. And then this 2 and this 2 will cancel. So your answer in this case is negative 1/2 n. So let me see if that works out for that. Negative 1/2 in parentheses. I don't know what is extra parentheses I do. To the, why so many parentheses coming up here? I don't know this. There you go. To the power of n. See what happens to the, if you like it or not. So as long as you know they are arithmetic and geometric, then you can use the formula. Okay. But now it's 12. 1/3, 2/9, 4/7, 27, 8, 81, and so on. Now, is this arithmetic sequence? Is this geometric sequence? The answer is no. This is not arithmetic. This is not geometric. So you cannot use neither of these formulas in question 12. So what you do if there are none of those, because in your finals, it's going to be not arithmetic, not geometric. It's going to be weird like this. So what you need to do here is you have to figure out what is your an term, like what we have did here. So what you label here, this is your n, this is your 1, 2, 3, and 4. So this is a fraction. So your an term is a fraction. So let's take a look at the top one here. Can you change this 1 to 1, 2 to 2, 3 to become 4, and 4 become 8? So how do you do that? Can you tell me what pattern you see on top here? Are they adding?
Doubling.
They are doubling, right? They are multiplying, right? So they are doubling. So when you're doubling, that means this is 2 to the power of n. But if you put 1 inside here, you get 2. But we got 1. Do you see that? So that means this one, so this is 2. And then when you put n is 2, you get 4. So what happened is that your n is 1 off. So you got put 1, you get 2. You put 2, you get 4. You put 3, you get 8. So it's 1 off. So since it's a 1 off, then this n has to be subtract 1. Because when you put 1 in here, you will get 0, which is 1. And when you put 2 in here, 2 minus 1 is 1, so you get 2. When you put 3 in here, which is 3 minus 1 is 2, it becomes 4. So you get the 1, 2, 4, 8. So this is actually is 2n minus 1. So first thing you always tell is, are you multiplying, are you adding or subtracting? Is arithmetic or geometric? And then after you figure out, are they doubling, tripling, so on. How about this one on the bottom piece? Are they adding or are they multiplying?
Multiplying.
then multiply by 3. So that means that this one is going to be 3n. And now put n as 1, you get 3. Put n as 2, you get 3 squared, 9. So this would actually follow very nicely. You put 3, you get 3 cubed, which is 27. So you find out that this one, you do not need to subtract 1. So this one will be 3n. So your answer for this case is 2 to the power of n minus 1 over by 3n. So usually if they are not arithmetic or not geometric, you have to kind of like dissect this, the top one and the bottom one, and then figure out what is going on here. You okay here? Is that tough? Now I let you guys do the last one, because this is in your finals next Monday. You just get ready for you guys. So number 13 is the last one. 1, 1/2, 1/6, 1 over 24, 1 over 120. Is this arithmetic? Is that geometric? Or is that neither? Is that arithmetic?
No.
That's correct. Is that geometric?
I don't think so, no.
Yep, because this is half. 1 times 1/2 is half. 1/2 times 1/2, it should be 1/4. This is 1/6. You know what I mean? So if you keep on multiplying by half, you won't get the rest of the term. So it's not geometric. So this is neither. So now my question is, now the an term, the top one is easy because all of them is 1, 1, 1, 1, 1, 1. So we know this is 1 over something. So my question is, what can you represent these numbers? And I haven't taught you that yet. Okay, so this kind of numbers is called factorial. What is factorial? Factorial is where you multiply, keep on multiplying the previous term. Okay, so if you have 1 factorial is 1. That means 1 times itself. 2 factorial is 1 times 2, which is 2. That's why you see the 1 and 2. 3 factorial is 1 times 2 times 3, which is 6. That's why you see the 6. 4 factorial is 1 times 2 times 3 times 4, which is 24. And then 5 factorial, 1 times 2 times 3 times. So 5 factorial will be 1 times 2 times 3 times 4 times 5, which is 120. So if you notice 1, 2, 6, 24, and 120 in your sequence like this is going to be n factorial. You guys with me here?
Yep, makes sense.
Yep. So so this is the hint when you see this in your sequence. 1, 2, 6, 24, 120, and then the next one is, what's 120 times 6? 720, because that's 6 factorial. That will be in factorial form. Okay, so you need to know some pattern. You know the 2, 4, 6, 8, 10, those are easy patterns, but this is a new pattern. We call it the factorial pattern. This is the number looks like. You guys good? And this kind of sequence and series will be used in calculus 2. So when you go to calc 1, and then after calc 2, then you learn again these sequences. You guys all right with this?
Yep.
Pretty much. So this is called a factorial. You see that? So make sure you. And by the way, 0 factorial is 1. YouTube this. There you go. YouTube it, and they will tell you why 0 factorial is 1, not 0. Okay. 0 factorial is 1. 1 factorial is 1. So and so on, so on. Okay. 18. You guys okay so far with this?
Yep.
Okay, let me go 18. Factorial. So what is 9n minus 1 factorial over by 9n plus 1 factorial? So if you want to write this is 1 times 2 times 3 times 4 times all the way till 9n minus 1. This one is 1 times 2 times 3 times 4 times 9n minus 1. Do you guys know what happens after 9n minus 1? So let's say you got 3, 4, 5, 6, right? You guys know this one, right? This is n minus 1. What's coming after n minus 1? How do you get from here to here? You add 1, right? From there to there, you add 1. From there to there, add 1. So how do you get from here to the other one? Because it's a geometric sequence. It's an arithmetic sequence. So
would it just be n?
You'll be n. You're correct. And what's the next one?
N plus 1.
What's the next one?
N plus 2.
Yep. So what's the next one of this?
9n.
And what's the next one?
9n plus 1.
Yep. And we stop here because that's what we told. We end here. And because they are multiplying, you can cancel every single one of this because they are the same. So your answer in this case is 1 over 9n times 9n plus 1. You got it? So
Yep.
these two will cancel. So make sure you guys know that sequences can be in not just number, it can be n form like this. Okay. All right. Now we do the summation part. So question number 19. Summation 8, k is 5, 9. So do you guys know what is this stands for? If I say summation, if this is a number, that means you add this number multiple times. How many times? Depends on your limit. This is what we call as limit. Depends on your limit. So if I say case 1 till 4, that means you add 1, 2, 3, and 4. Okay, but this one stays 5 till 8. So this is number 5. This is number 6. This is number 7. This is number 8. So this K5 means that this is A5, A6, A7, and A8. And the reason why we stop at 8 is because this is your stopping point. And every term is 9. So what is 9 plus 9 plus 9 plus 9?
36.
This is 36. You okay there?
Yep.
So if you have, this is a number, like what we have. But once you see that it's a K in front, then you have to substitute. So what you do for question number 20 is you have to plug in, because there is a formula, but this case we do not want to do the formula. So you plug in K become 1 here. So you had to plug in K become 1. What do you get? 3 times what? 3 times 3 square minus times my negative 4, right? Because when you plug 1 here, you got 3 square. When you plug 1 here, it comes negative 4, right? And what is 3 times 3 square, which is 27? What's that going to be? And 3 times 9 times negative 4. 3 times 9 times negative 4. This is negative 108. And then you do the same thing for k is 2. So you plug 2 inside here. You will get what? 3 times what? 2 times 2. 2 plus 2 is 4. 4 squared is 16. And then 2 minus 5 is negative 3. So this is actually is 9 times 16. That is negative 144. And you're going to do the same thing for 3. And where does it stop? It stops at 6. So you're going to do 3, 4, 5, and 6. And you got all these numbers once you plug in there. And what you do with all these numbers after that?
Add them all up.
Yep, you have to add all this up. And the sum of this will be your answer. You got what I'm saying?
Yep.
Yep. Unfortunately, for question 20, there is no shortcut. Even the formulas doesn't work here. So this is the only way to do it. Sometimes you can notice a pattern because once you plug 3 in here, if you see there's an arithmetic sequence, you can use the arithmetic formula, but I think this is not arithmetic or geometric in this case. But for number 21, we can do the same thing. So when you see this, you put 2 here. So when I is 2, you get what? 2 squared, which is 4, right? This is easier. I is 3, what you get? 2 to the power of 3 is 8. I is 4, what you get? 2 to the 4th is 16. And the last one is I is 5. What is 2 to the power of 5 is? 32. And then you just need to take your calculator, add all this up, and that is your answer for 21. You okay there?
Yep.
So again, this is the very basic stuff because once you go to calculus 2, you begin to know all these formulas, and their formulas are horrible actually. So that's the reason why I didn't teach you the formulas here. So this is actually the basic stuff of it. So the next one they want you to do is they want you to write this as the summation. Okay. So how do we do this is first, you notice that it starts at 1, and notice the top one of 4 over 7 plus 1. So can you tell me where is this going to be stopped? It starts at 1. Where does it stop? And where does it tell us from this whole thing where it stops?
15.
Yep, 15. So every time when you look at this, you look at the last follow here. And the 1 means this is the 1, this is the 2, this is the 3, and that means this stops at 15. And what is the formula we use? It's going to be 4 over by 7 plus I. Because your I in this case is 1, 2, 3, 4, 5 to 15. You okay there?
Yep.
Can you tell me on number 23, where is this stop to? It goes from 1 till what?
11.
11, because that's the only number that is changing. 1, 2, 3, that's 11. So what is your answer in this case? Is exactly the same as what? What is the argument they call it? 4 minus what? Parenthesis. That 1. This
K
one,
over 6 squared.
Yep. K over 6 squared. Yep. I don't know how to put it. I don't know. Make sure you put parentheses around it. No. There. You okay there?
Yep.
This one is tough. Eight minus 64 plus 512 and so on. And then negative 262144. Now, the reason why the last two is easier because they're all in this kind of notation. That's why it's easier. But number 24 is tough. So you have to make this as a notation, a power notation. So can you tell me how you get from 8 to 64 to 512 and so on, so on, so on? Is that an arithmetic or is that a geometric or is that a neither? What do you guys think? 8, 64, 512, 4096, so on, so on, so on.
Geometric?
This is geometric, yes. How you get from 8 till 64? Multiply this by -8, right? And how is 64 to 512 to -64 to +512? You multiply it with it. So that means that your R in this case is what?
-8.
-8. So can you tell me what's the AN that you told me last time?
A of 1 R to the n minus 1.
And what is A1 in this case?
It'd be 8 and then -8 n minus 1.
And where do we stop? This is n is 1, this is n is 2, this is n is 3, 4, 5, and 6. So what is you put in here?
6 right there.
6. And then this one will be exactly the same as your AN. So it's 8. If you want, you can do the trick that I showed to you. 8, -8n to the power of -8, -1. I separate this like last time, right? And what you guys can tell me with this one? This -1, what we do with him last time? We flip it, right? So don't forget, when you have -1, you flip that fellow. And the 8 and 8 will what? Cancel out. So your answer is -8 to the n. So, but we don't use n here, we use I. So last time we used k, this time we use I. So it's -8 to the power of I. So usually when you guys do this kind of work, usually this is the top part. This is your AN term that you know that last time you find. Remember the AN term? You put it right over here. You guys want to try to do the 25? Yep, good. Yeah, you guys are good. Yeah, arithmetic. No, Brenda's geometry. 25. Where do we end at?
7.
7. Yep, it ends at 7. Can you tell me what is the formula we use here? They all have 2 on top, so we know it's 2 over by what? So 1, 2, 3, 4, 5, 6, 7, we know is k, right?
K plus 1?
Times with k plus 1, yes. Because when k is 1, you get 1 times 2. If k is 2, you get 2 times 3, because 2 plus 1. And then same thing the rest of it. Yep, this is your answer in this case. Again, this is very useful. This is calculus 2. You need to know this. So when you go to calculus 2, the first thing when you learn after you do finish integration is you learn this one. Okay. What is the meaning when I say the fourth partial sum? The fourth partial sum means that 26 is when you put I is 1, I is 2, I is 3, and I is 4. That's called find the fourth partial sum. So that means that you just put I is 1, figure out what is that number is, which is 4/3, right? And then I is 2, you figure out what is that one is, which is 4 over 9. Because you square it, so 1/9. And what happens when I is 3? It's 4 over 27, because 4 times 1 over 27. And you know what is 4 is when I is 4? It's 4 over what? 81, because the 3/4 is 3 times 3 times 3 times 3 4 times. So what happens to find the fourth partial sum? You take all this and you add it. And that will be your answer for 26. You guys all right here? Yep. Questions? Okay. How about number 27? Now we don't use the partial. If I ask you for 4 partial sum, that means you go up to 4, right? Or 6 partial sum, you go up to 6. But this time is infinite, means that you keep on adding. So when you put k is 1, you get 1/10. When k is 2, it's 1 over 100, because 10 times 10 is 100. When k is 3, it's 1,000, and so on and so on, right? And this keep on going, because you need to find the sum of this. Keep on going. What is 1 over 10 in decimal?
0.1.
0.1. And what is 1 over 100 in decimals?
0.0.
And this one is 0.001 and so on. So when you add all this, what you get? 0.111111111. So actually, this number 27 is actually 0.1 repeat. Do you know what is the fraction represent on this case? Then that will be your answer.
1/9.
Yes, this is a 9th. So your answer in this case is 1/9. This one is easy because this is 1/10, this is 2/10. So when you add this, you won't get 0.1111 because of the 2. You get point what? 0.22222 because of the 2 in front. And what is that represent in fraction? If this is 1/9, yes, this will be 2/9. You're correct. So make sure you understand. Some of them is very easy. Again, you need to know all this. This is so important when you go to calculus too, because make sure you know some decimal representation, like all the ones is 1/9, which is, you guys know, that's good. All right, so this is mostly what is going on with your sequences here, some sequence and series. So I think you guys are all right. No problem, right? This one you guys doing good here?
Yep.
Okay, this one you plug 1, 2, 3 till 8, and then 80 after that. And then this one is the same thing. Oh, what happens when you have a 0.3? Just a number. Last time when you have a n, you plug 1, right? What is 0.3?
Are they just all 0.3?
Very good. Yes, this is all going to be 0.3. So if you just have a number without any variable n, A1 till A, whatever you have, is all 0.3. Okay, good. This one, you just need to put 1, 2, 3, 4, 5 here, and then add everything up. Same thing, you put 0, 1, 2, 3, 4, and then add everything up. You guys okay here?
Yep,
not too bad, actually. There are formulas for these two, but I didn't show it to you. But just keep it simple. Otherwise, the formula, when I introduce, you will learn this formula in Calc 2. Okay. Now, arithmetic. I think arithmetic, you guys are doing really good, right? So you learn about the arithmetic sequence, which is if you want to find the term, the nth term, the formula is A1, or not this one, it's n minus 1d, not n plus 1. Okay. And this formula is the sum of the sequence, the arithmetic sequence. It should be a finite. The reason why we don't do an infinite arithmetic sequence is because the sum is going to be infinity. Because what happens when you add 2, 4, 6, 8, 10, keep on adding till infinity, 2 plus 4 plus 6 plus 8, all the way, it will be infinity. So it's going to be always finite. And there is a another formula for you guys for the sum. This formula is where you know the first term and the last term. So if you know the if you know the whole sequence is an arithmetic, you know the first and the last term, you use this formula. But if you just know the first three terms but doesn't know the last term, what you do is you substitute this an that you have here into here. So when you have that, n over 2 a1 plus an, this is where you know the last term, the first term, and the last term. So if you have a sequence that give you an arithmetic sequence that you know the first and last, but if you give you the first 3, 4 term, you don't know the last term. So what you do is you replace this with this formula that you guys use for the term is a1 plus n minus 1d. So, and in this case, we got 2a1 because you got a1 plus a1. So plus n minus 1d. So this is the formula you will use if I give you like 4, 8, and then 12. And then I want you to add up to 1,000 terms. So we know the first 2 terms. So then we use this formula. But let's say the 1,000 term is 4,000, example. Then you just use this formula because it's quicker. You guys with me here?
Yep.
And you guys are very good to distinguish between an arithmetic and a geometric. Arithmetic, we use the D, which is the common difference. Like this is an arithmetic difference because you keep on adding or subtracting, in this case, adding 7. This one is that arithmetic. This is arithmetic. Number 5, is that arithmetic?
That's geometric.
That's geometric, yes, because it is dividing by 2. So this is not an arithmetic sequence. This one, this is not an arithmetic, and this is also not a geometric. Remember last time we can have neither of those. This is neither belongs to. You guys all right here so far? Questions that you have with arithmetic? Arithmetic is actually pretty much simple. Oh, let's do this. Let's do one question that looks like. Okay, let's do like this one. This one is easy because you know the D. Let's do this one. Because they don't give you D. They give you the A4 and A10. If you know the D, you should be able to do all these things. So do you know how to find the D in this case?
Yeah, there's the other formula, ay minus ax over y minus x.
So that is for ratio. So when you say over, that's geometric. So what you do here is you can find D using your formula. an minus 1 minus an plus 1, sorry, minus an, this is D. Okay. So that means that if you want to find D here, you can subtract 47 and 29, but you will get 60. Do you know where I get the 6 from? 47 is from here, right?
10 minus 4.
Yes, the D came from the difference of this. So in order for you to find D, you just need to divide this by 6. And that's your D. And once you know your D, you can able to find your A1, A2, A3, A4, A5. A4 is given to you 29, right? So if you know your D, what's your D here? 47, take away. So this is a
3.
if the question, I'm sorry, 3?
Yep.
3. So that means you keep on adding 3. So this will be 32. And you keep on subtracting 3 here, which is 26, 23, 20, right? 3, 3, 3, 3. You okay there?
Yep.
So if a question did not give you A1, A2, they give you A4, A10, and all these separate ones, then you have to find D using this formula. Okay. Questions? Now, this is easy because we know the first term, we know the last term, Do we know n here? You just count. 1, 2, 3, 4, 5, 6, 7. So n in this case is what? 7, right? So these formulas are very easy because you do 7 over 2, because you got 7 of them, and then 3 plus 21. You guys with me here?
Yep.
This is easy because you can count them. Now I'm going to give you a special one, number 14. 3 plus 6 plus 9 plus blah, 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 blah. And I am going to give you something big because in your test, it's not going to be as easy as that. I can tell you that. Let's take 183. So if you got this, you can count 1, 2, 3, 4, 5, 6, 7. That's why we know our n here is 7. But now we figure out this one, 183. So the formula is this formula because we know A1, which is 3. We know AN, which is the last term, 183. But my question is, do you know what is n in this case?
No.
No. Last time I teach you by, oh, you can do n by counting. This also you can count, right? This is 6. Do you want to put 3, 6, 9, 12? You're going to do it, and then you count 1, 2, 3, 4, 5, 6, all the way to 183. You can, but you spend a lot of time, right? Do you guys know a shortcut to do this one to figure out what is your n here? Yeah, you can do it the long way. I show you to you 12 and then 15 and then you after you do 183 you count 1, 2, 3, 4, 5 that we just did, but I don't want to do that. The formula is using your AN formula. Remember your AN formula? A1 plus n minus 1d, right? Remember this one you told me earlier on? And you can find this term, 183. You can find what's n term. So A1 in this case is 3. N minus 1, and the d in this case is the difference. In this case is 3. And you solve for n. Then you can solve for n, right? Go ahead and solve for n, what you get? So subtract 3 is 180. And then divide by 3. Don't distribute this. Divide by 3. 180 divided by 3 is what? 60. And then you add 1. So n in this case is 61. And then now you plug it into this formula. 61 over 2. First term is 3, and the last term is 183. And you get your answer. You okay there?
Yeah.
So if the question gives you a lot of numbers, then you have to find n first using this formula. And after that, you use this formula to find your sum. Okay. But if you have a very short one like these two, then you can just, you just count them. You okay here? This is easy too. This one, 18. 100 n is 31 n minus 30 n is 1 n. So what is this? Sorry for my bad handwriting. What is this stands for? This stands for, anyone know what does this mean? N is 31 to 100. So that means you have to add from where to where. 31 plus 32 plus 33 plus all the way to what? 100. This is an arithmetic sequence. So we can use this formula, the one that I just showed to you. But we know the last term, which is the first and the last term, which is 31 and 100. Do you know what is your n term here? So first term is 31, 100. You can count 1, 2, 3, 4, all the way to 100, but does anyone know?
69 or 70?
Ah, very good. So you got two choices now. It can be 69, it can be 70, it can be 71. So which one is correct? Yep, this is one of them. Your n is this, and they all give you different answer, right?
69, I think.
Okay, just count for me. So let's count 31 to 40. How many you have? 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So 31 to 40, you got 10, right? So what do you think about 41 to 50? How many you have? Also 10. So what do you think about 31 to 100? Is that 69, 70, or 71?
70.
Yes. So you get an answer here. And then you do this case. This is 1 plus 2 plus 3 all the way to 30. And what, same thing, same formula. So what is your n in this case?
30.
Yes, 30. And then once you get this answer, what you do with this 2 is you just subtract it, because the answer is asking to subtract, and you get your answer. Okay. Now, I can be tricky in the test. I can put a 0. This is 1, right? I can put a 0 in here. No, put 0 in there. Yeah, no. No. The reason why, let's say I wouldn't be tricky here. Let's put this as 30. And this is 29. And this is 1. So what? This is the same thing. This is 30, the same thing, right? But now what is my n in this case if I change this from 30? 69, 70, 71. Yes, 71. So be careful with, if you have a 0, like 30, 40, 50 to another 0, it's not 70, it's not the 0, it's another 1, because of the 0 count as another 1. You know what I'm saying here? Like you count,
yeah.
1 till 10, you got 10. But if you include 0, you got 11, because the 0 is the 11th one. You with me here?
Yep.
Yep. And you guys need to think about this, because in calculus, this is what is challenging, because you have to think something like, and they're tricky, because just one little number like that, it will change the whole sequence here. Okay. The rest, I think you're fine with it with arithmetic, because it's only fixed. I only got 2 formulas in arithmetic, so I think you are good with arithmetic. But the one that I'm worried about is the geometric sequence, because geometric sequence has quite a few formulas. The formula to find the n term that you guys told me early on, which is this one, a1 r to the n minus 1, that is correct to find the nth terms. But in the geometric sequence, we got 2 types of sum. Okay, 2 types of sum. One is called the finite sum. This is for geometric. And one is for the infinite sum. So the finite sum of the geometric sequence, oh my God, I forgot the formula. I think it's A1 minus Rn. I think it's this one. Ooh, this is not good. I forgot the formula. I think it's this one, 1 minus Rn over 1 minus R. I think that is the formula for that. Sorry about that. I think that's the formula for that. I think so. Oh my God. I think this is the right formula. Let me check. That's easier. Just check. I think it's the correct answer. Yes, it's correct. So again, sorry, it's been a long time looking at the formulas here. So again, the sum for the finite one is given us by A1 1 minus Rn over by 1 minus R. Okay. So how do you know it's a finite and infinite? It's very easy. So if you see dot, dot, dot like this, it's infinite. So if you see a dot, dot, dot behind, it's infinite. If you don't see dot, 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 it's finite. You guys know that? Okay with that one? That's how I can tell you, and that's how you should. And another way you can tell if I give you a sum is this number. If you see a 7 or 8 or 25 or 100, that means this is finite. And this one, see, they have no dot, dot behind. This is finite. If it's an infinite, then you have an infinity symbol on top, or you have a dot, dot, dot behind like this. Then this is infinite. So for the sum of the infinite sum is A1 over 1 minus R. But this is a rule for this. If you want to use this, your R in this case has to be between 0 and 1. That means that it has to be converged. So if you have like 1, 2, 4, 8, blah, 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 we know this is this is all for geometric sequence. We cannot apply this here is because your R is 2. Because 2 over 1, you multiply everything by 2. So, and because if you keep on adding this, it will go to infinity. So that's why there's no point of you find the sum of the infinite if your R is greater than 1. You don't find it because we know the sum will go to infinity. But this is for infinite case. But if you have this case, and this is called this is called converge, and this is called, oh my gosh, that's called converge, and this is called diverge. I think so. Oh, cow to forget everything. Like 1/2, 1/4, 1/8, 1/16. So this, the R in this case is 1/2. So this is actually will be diverge. Yeah, no. I think I got these two mixed up. This is diverge and that is converge. Divergent sequence and convergent. Yeah, this is converge. And it will converge to 0. That means that if you keep on cutting this by half, it will getting closer to 0. So that's the reason why that this you can use the sum of this case because your R is not greater than 1. So you guys got what I'm saying here? Yep. So that's the reason why that for like this case, we know this is your R. If you got this case, I can tell you this is your R because if you know your formula is A1 R over n minus 1. So this R is -5/7. This is your R. We know this is going to be a converged sequence. So this has a sum for the infinite geometry series. This one is also getting smaller. So 81, 72, 64, 51. So if you find the sum is getting smaller and smaller and smaller, which is converged in this case, then it does have an infinite geometric sequence. But if your sum is getting bigger, like your sequence, like 1, 2, 4, 8, where it goes towards infinity, then then you cannot find the sum of the infinity in this case. You guys all right here?
Yep.
Just want to point out to you, yes, I just want to point out to you again, the one inside, if you have a geometric sequence, the one inside the parentheses is your R. So this is the fastest way to find R. And you also have to be careful with your A1. So for example, is if you got this kind of like number 17, this is all little tricks I showed to you, so you know. Because your summation here has 1 in there, your A1 will be 20. So it looks exactly like, so you see this formula? It looks exactly like this formula, right? See the I minus 1. So do we know this is your R? This is your A1. But if you look at this formula is different from here because this is n. This is n minus 1. And if you look at number 19, your summation doesn't start from 1. It starts from where? It starts from 0. So in order for you to find A1, you have to plug 0 into this question. In this case, would be 6. See that? Oh, in this case, your A1 is, your A1 is 1 here. So you get 0. So that is a tricky part that if I give you something like this, this, do you know what is your A1 is? The R is 1/3, we know that. Anyone know what is A1 in this case? Last time here is 6, right? This one, what happens when you plug a 0 inside here? Is 6 to the power, 6 1/3 to the power of what?
-1.
-1. And again, remember this one I told you before early on today class, you can flip this, the -1, you flip him. So it becomes 3. So A1 in this case is what? 18. So just want to point out to you guys, R is always inside this parenthesis, but A1, the best way for you to find A1 is to plug in whatever the n equals to over here, or I equals to into this formula. That's the best way for you to find A1. Do not assume that your A1 is 20 and your A1 is 6, you know, the one right outside it, because it can be like this case I show it to you, where the A1 in this case is not 6, but it's 18. You guys all right?
Yep.
So those are little tricks I want to tell you because I know what's going on as a teacher. Mostly a lot of you guys will have the, will able to do this. The only thing is, again, geometrics, sequence and series, all full with formulas. And the geometrics have 3 formulas. This follow, that this is for the sum, and the one that you told me early on for the sequence A and A1 R n minus 1. So make sure you guys, this actually is not difficult, the chapter 11. It's easier than the sine and cosine and the tangent and all those things that we learned so far. Okay, so don't forget, it does come up in your finals, so make sure you guys also practice this. So just want to point out to you guys, your homework for today, that is due today. You got 2 sessions of homework due today, which is 8, 6, and 11, one that is due tonight. And then on Sunday, before your finals on Monday, is 11, 2, 11, 3. So that means all this has to be done before you do your finals on Monday. So you got 4 homework. This is the last 4 homeworks that you have to do. Okay, so that's it for today's class. You guys, and I also watched the videos. I think I post some videos. I think you guys are okay with this sequence and series. I'm not worried about that too much. It's mostly the formulas and some rules that I'm pointing out here. The rest is pretty much, you guys got it. You guys have any questions here for me?
Nope.
Before I stop.